Good morning. Myself Sangamesh. I am from Cambridge North Campus. I am today here to explain my topic, my project, which is credit score analysis and prediction. So initially we have imported some of the libraries which are essential for this analysis and prediction. My project dataset has 100 rows and 15 columns, where we can see that there are the 15 columns which include consist of 10 float values and 5 object, where the target value is credit score. This is information of the my data which shows the average age of this dataset is 46.5, and most of the people has 6 number of credit cards. The average saving balance of this dataset is 1,02,560. The minimum employment years is 0.03 and the maximum employment years is 39.83. The most of the people has a marital status is single. So initially we contain some of the null values, as we can see, and the loan times has the most of the null values, where for other values it is around 50, but loan types has more than 250 null values. So we have to clean the dataset so that we get a clean model. We clean the dataset by using average method, where I use mean for numerical expressions and mode for objectives, which is high frequency, which has highest frequency. This is all the data cleaning structure, where I have used average of all the values. After the cleaning, we have 0 null values for every column. Next, we study of the graph. So we can see that most of the people has around 600 credit score. That is around 135. Next, I have classified the dataset credit score as very poor, poor, fair, good, and excellent, where it starts from 300. 300 to 500 is very poor, 500 to 650 is poor, 650 to 700 is fair, 700 to 750 is good, and 750 to 900 is excellent. Then we can see scatter plot of credit score with employment status, where we can see the most of the people has lesser annual income or of higher age. Like you can see this 70 is mostly below the mean value. Then we plotted box plot of employment status with credit score, where we can see unemployed people has the highest range, where employed people has the good credit score, which is valid. Next, we have a box plot of credit score with respect to loan types, where auto types only loan has highest credit score, and the other two has same types of lower credit score. Next, we have box plot of education level with respect to credit score. We can see bachelor has highest credit score, whereas the others does not have the highest credit score. Next, we have box plot of resident type with respect to credit score, where we can see rent people has the highest score, but as the data is dummy, we cannot say it is a valid data set. Next, after the grouping, I have plotted a count of age groups, where we can see there are most people are from 40 to 50 age groups, and our average value is of 45, so it is a value. And we can see our data set consists of civils category, where very poor has the highest percentage of 33.6, and poor has the next highest, which is 30.6, and the least is 8.4, which is fair. Next, we have a pie chart of distribution of education level, where we can see the most of the people are from high school, and the least is bachelor. Next, we have a box plot of credit score across age groups, where we can see it has a highest range for 10 to 20, but a highest credit score for 20 to 30 people. This is the bar plot for credit score distribution across number of credit cards, uh, which is approximately same for every number of credit cards. Next, we have a scatter plot of age versus credit score value, where I don't think age should be a value for credit score determination. Like age of 60 people who doesn't have any loans or anything with the banking related, he can have a low credit score value, and a youngster like 25, which he has a, if he has a credit score of more than 700, it is good, then he must have taken loans and paid it at the time. So it doesn't affect the data set. As you can see, it is spread all over the data sets. Next, we have done OLS module, where I have included, initially I have included in the X variable, I have just included the numerical types. I have dropped all the object types, as you can see. Next, in Y variable, I have inserted target value, which is credit score. When we saw the accuracy, which is very low, it is around 0.619, it is very low. Then so which, to which I have used dummies, so that I can convert the object type into bool, which I can further divide into 0 and 1, which I have done it. After dummies, we have got many columns, which I have converted into, which are of bool type, so I have converted into float type, as my other data sets are of float, so I have converted to float, so there is no data loss. Next, we have same including the all the variables in the X, and in Y it is target value. Then we saw that it is certain increase of around 4 times, which is 2.5. Next, we have done classification using neural network, where I have used same classification as I have showed above: very poor, poor, fair, good, excellent. The most is very poor, poor, next fair, next good, and excellent. Fair has very least values. Then we have used label encoder for labeling of all the values. I have labeled very poor as 4, poor as 3, and so on. After training the model, uh, when we tested it, these all are the training set, where I used 100 approx. Callbacks as early stop. Whenever it has a good accuracy, it will stop. And I have split of 0.2, which is 20% of data is used for testing. We got an accuracy of 30%, which is better than the 2.5 of OLS module. Next, we have done classification using ML. I used random forest. I have used same null values for this, the dummy values. I have dropped civil category and civil score, as they are our target values in the X variable. When we tested it, I have used random classifier, random forest classifier. When we tested it, we got an accuracy of 40%, which is better than neural network classification, which was 30%. Then I have plotted correlation matrix for the dummies, where you can see there are no highly related variables, not even one. So the accuracy is low. And next, we can see that for the actual data set also, there is no highly related variables, since the accuracy is very low for neural network classification, and also for OLS and machine learning classification. Next, we have built an user interface using radio, where I have done the module of credit module, but there were 29 columns, so it is hard for the user to plot give input for 29 variables. So since there are very less relationship in my dataset, I have considered top. I saw that the top 10 relationship have, in which the top 6 have 0.07, then it is, I don't think it is valid. So I have only taken top 6 features which are affecting the dataset. Then I have created again one more module which which I have dumped in the Gradio, and the Gradio gives an output of credit score, which, and it should also classify the values, like if it is 600, then it should be poor. So this is the classification which I have done here. After building Gradio, I have used custom CSS for background and for background. After creating this, we can predict the credit score of the user, where we can see these all are the values which I have put previously. This, it shows that it is a good value, good credit category is good, and predicted credit score is 723. Uh, Consider we will outstanding debt is around 1,20,000, and saving balance is like 2 lakhs. Annual income is 50,000. Employment years is around 15 years. Credit history is 4 years, and age of 21. Uh, Here we can see that the credit score value is 620, which is poor according to my dataset. As our dataset has most of the values which are related to very poor and poor, the most predicted value should be very poor or poor. That's all from my side. Thank you.